My name is Andrew. I'm the founder of dstack. And at dstack, we are building an open source container orchestrator specifically for managing AI infrastructure. And we are basically helping AI teams that want to train and develop models over any cloud providers or on-prem, and they are not satisfied with traditional orchestrator tools such as Kubernetes and Slurm. And basically, I'll go into more details why we do that and how this works. Right. First of all, when it comes to managing infra, regardless whether which cloud you are using or whether you're doing it in data center, most CSPs at certain point provide you proprietary MLOps platforms and tools to basically train and develop models. At the very end, as a company, if you are a team of developers and you'd like to do that at scale, eventually you are start to look for open source stack, for a stack which is not like locked into one vendor, which is based on containers, where you can bring your frameworks, your scripts, your data, and you can control where you want to run it. And this thing is called orchestration. And containers play a key role there, because containers help you make your workloads portable. Means that you can run them across any different cloud compute or on-prem, and you have 100% control over what you run. When it comes to traditional orchestrator tools, the problem is that most of them were designed before the AI era. And of course, we all know Kubernetes is a standard de facto, and it's supported by every cloud platform. However, if you ever worked with Kubernetes, you know that Kubernetes is built for SRE and DevOps, and its interface, it's tailored for production-grade deployments. That's why it's really great at deploying software, web services, and at scaling it. However, when it comes to managing AI infra, there are other challenges that come into play. On one hand, you actually need a way to manage and allocate clusters across your team, and also enable your team to cost effectively use these clusters and queue your training jobs. When it comes to developing your models, you often want to fine-tune and train models. Of course, it depends on the scale at which you do that. There are teams that fine-tune smaller models. There are teams that do pre-training of larger models using larger scale. But whatever the case, at the very end, you need an interface for your AI engineers that would train models. And of course, while Kubernetes solves a lot of issues at scale, it doesn't offer you an interface for your AI development team. And as much as we love Kubernetes, as much as we see a lot of happy Kubernetes SREs and DevOps, we never see happy AI engineers that have to use Kubernetes. For a good reason, because eventually, if you are using Kubernetes, you have to build on top of Kubernetes. You have to bring your platform team. Now you have to bring a lot of DevOps. So they built internal platform for your AI team. And then the problem is that you start to have this friction between your AI development team and your platform team. And well, the biggest reason why platform team is hated quite a lot is because it's the team that tells you no. AI developers, they come often, and because, well, the platform team controls the infrastructure and everything, basically it becomes a bottleneck. And if you are a company that would really want to accelerate AI development and really do training at scale and inference at scale, you certainly don't want to have this bottleneck. That's why Kubernetes is what slows down your AI development team. And we work at dstack with multiple teams, larger enterprises that originally started to build on top of Kubernetes, and eventually realized that it slows them down, and instead of spending more time with data, with models, with training, with the experiments, they spend a lot of time building internal platform and making it work for everyone. And of course, developers really want this flexibility and everything. And it's tremendous amount of feedback we get from those teams that use Kubernetes. And there are two things that they are typically looking for. One is simplified interface. In the end, AI researchers, they are not DevOps. They want a simple interface. This is my training job. Yes, it should run on a cluster. This is my script. This is my Docker image. I just simply want to run it. I want to use a dev environment as well, and I don't want to build internal platforms. That's one story. The other one, what we also often hear from these customers is that in order to make Kubernetes really efficient for AI, you have to bring a lot of custom logic on top of Kubernetes. You have to bring custom operators. Kubernetes itself, well, as much as we love it, it's not accelerator aware. We have to bring these labels and we have to manage these nodes at Kubernetes, and that involves a lot of basically administration and DevOps involvement to make this Kubernetes cluster highly usable by the development team. So that's one problem that dstack tries to solve, and in a minute I'll expand on how exactly we do that. On the other spectrum, end of the spectrum here, we have research labs and academia teams, well, with academia background, that have to use Slurm. Slurm is also an orchestrator in the end, and it was designed through this HPC era, mostly for simulation. However, now supercomputers are mostly used not for simulation, even though that's also a thing now, but it's mostly used for AI, for training, for inference. And Slurm, being a previous generation orchestrator tool, it also has a number of gaps, let's say. So one gap is, like Slurm has, is that it's great if there is somebody managing that cluster. It installs Slurm there and somebody manages it for you. But as soon as you want to change your cluster or you want to introduce multiple clusters, Slurm doesn't help you manage clusters. It doesn't solve the problem of provisioning. Whenever, for example, you work with a cloud provider as Vultr, you'd like a tool that would let you provision. Today you need a cluster of 100 nodes. Tomorrow you need something else, and you want to enable your AI team to provision that on demand and not basically after a long approval with the platform team. You need the infra where you actually need that. Second, Slurm is focusing a lot on heavy jobs and trainings, but often as an AI development team, you also have other use cases. You need dev environments, right? You want to use your desktop IDE to work with a remote machine, to do experimentation, to use the terminal and notebooks and run your scripts before you can submit a training job. And all of that you want to do while accessing, tapping onto the infrastructure and compute that you have set up within the company. And while in some simple cases you can use SSH and directly log in into one machine, now imagine a team that would like to reuse the compute cost efficiently, and you certainly need something more than what Slurm offers you. Then one more thing that Slurm has in terms of the gap is also inference. And inference, as we know, it's not only production grade inference. A lot of, like very often, you as a development team would like to experiment with the inference. You'd like to run a model as an endpoint. You'd like to enable your rest of the team, maybe product team, to build on top of that endpoint, even long before this endpoint will go to production. And as an AI team, you don't always want to go immediately to the DevOps team and start basically working with Kubernetes. As long as you are involved with development and testing and staging, you need a more lightweight way of managing compute. So that's where dstack steps in. Also, what you probably observe a lot is that whenever it comes to, as I said in the beginning, working with the cloud providers, they always happy to provide you a proprietary platform. But as a developer, of course, you'd like to have a vendor agnostic way. A way to run your containers without necessarily being locked into one particular vendor. And even though you are interested in using one particular vendor, you also might be very much interested in bringing your frameworks, bringing your scripts, and not being constrained by this. So this is where dstack comes in. You can think of dstack as a container orchestrator, just like Kubernetes. It does the same thing. However, there are a number of differences. Number one, its interface is tailored for AI development teams, not for DevOps, but for AI engineers, AI researchers. It offers certain abstractions, which I'll introduce in a minute, that are friendly for AI teams. That's one. Second, dstack natively integrates with cloud providers such as Vultr. And Vultr is a now also GPU aware cloud provider that wants to offer you everything that you need as an AI team. And thanks to the native integration between dstack and cloud providers, whenever you request any compute, you request very specific compute. When you run something, you request very specific GPU, you request a cluster, dstack makes sure then it provisions it cost efficiently, and also, for example, when you provision a cluster, it provisions a high performance cluster. So basically, dstack serves an interface between your AI team and the compute provider, which is a Vultr, what I'd like to talk about here. In this diagram, you can see what layers are here and how dstack interacts with them. On the very bottom, we see, of course, the NVIDIA as a hardware. In the very end, we need GPUs, and these GPUs are NVIDIA GPUs. On the level higher here, we have a cloud provider, Vultr. And Vultr offers multiple things here, but what we are interested in as an AI team, two things. Public cloud, it's on demand. It's something that is much easier to use. You need a GPU at certain quantity, you tell that, and you have it on demand, right? Without long commitments. On the other hand, if you'd like to tap into larger clusters and more high performance clusters, this is where private cloud steps in, where you might start to have certain commitments. And if, for example, if you want to go like more than 100 nodes, like several hundred nodes, this is where the private cloud would be used. And on top of that, we have dstack as an orchestration layer. And as you see, it sits on top of the cloud provider, and it abstracts out this cloud provider from you. You don't have now to think of where the compute is coming from, as long as it's your Vultr cloud account. It can be private or public cloud, but most importantly, dstack offers you abstractions. It offers very simple abstractions. Dev environments. It's when you want to use your desktop IDE for working with remote compute. You need a GPU. You just tell which GPU you want to use. Your Git repo, like your Docker image if you have any. And then dstack helps you provision that dev environment for you so you can use it. And it's not only you, it's also the team. Once you have set up dstack server with your Vultr account, you have multiple projects and you can bring team members, and dstack helps basically allocate that compute across your team, and you can use these hard compute services more cost efficiently. Then another abstraction that dstack offers is tasks. Often, once you've done some experimentation, you want to now schedule some training or fine-tuning. It could be large or it could be small. It could be run on a cluster. It could be pre-training a large model, or it could be fine-tuning a small model. But just like Slurm, you need an interface also, in addition, for example, to dev environments, to schedule jobs, to queue them, and have a simple interface of doing that. Third thing is, what I mentioned earlier, is services. Sometimes you want to, okay, I want to run this model as an endpoint, and I want to share this endpoint with the team so I can build RAG on top. But I do control everything under the hood, and in a minute I'll show you how all of these abstractions work. And maybe two last things here to mention. Fleets. Fleets, this is how we call clusters. And as an AI team, sometimes you really want to have a control over the cluster lifecycle. It's not that something that you ask your IT department to provision for you, but it's something that you'd like to be able to provision yourself. Today you need a 100 nodes cluster, tomorrow you need something else. dstack offers that abstraction, and I'll talk in a minute how this works. And finally, of course, volumes. It's really hard to use compute without high performance persistent storage, because you want to store state, checkpoints, data across your runs while your workload is running with Vultr compute. Right. And because dstack is a container orchestrator, it means that you are inside a container and it's portable. It means now you can bring any Docker image. and you can build your own Docker image. You can take a Docker image from the community. For example, you are interested in inference, and you can take a VLLM Docker image, or you can take a certain fork of that or version of that that is optimized for your use case. You can make your own version of that, and same for training. And of course, you can bring your own data. You can use any framework you want, and this tech doesn't tell you which framework to use. But now let's look a bit more in detail how this works. I want to give you an example of how developer experience actually looks like. Starting from very simple one, dev environments. Just like I said, before you do something super complex, you want to run some experimentation. You just want to use your IDE or terminal or notebook, and you want to just run it. But one thing, you actually need GPU. You need sometimes one, sometimes many. You still want to use your favorite IDE, right? You still want to use Git. You still want to use your Git repo. And this is where dstack steps in. So everything you do with dstack goes through configurations. You define a YAML configuration, then you do dstack apply. And then dstack apply, just similar to how Kubernetes work, it materializes what you configured. In this particular case, in our project repo, for example, imagine that we create this dev environment. And we say, OK, this is the name of dev environment. I may specify Docker image, or I may just say which version of Python I want. And then which version of the IDE I want to use. It could be Cursor, VS Code, anything, and then of course you tell how much GPU you need, and then what you do dstack apply through the dstack CLI, and dstack would automatically provision this compute within your Vultr account. And it will do so within the quotes that you have configured within your tenancy. And then also everything you do with dstack is within the project, and you can have multiple projects within dstack where you can bring team members, and you basically see who else is doing what within this project, but projects isolated from others. These are basically units for teams to make it easier. And once you provision these dev environments through dstack apply, dstack would show you the URL which you click, and your desktop IDE VS Code will just open that remote environment. Nice thing here is that dstack automatically handles port forwarding, fetching your Git repo there. You just click that link, and you now have your Git repo open inside Vultr's compute, running with exactly the GPU that you requested. All secure and using your personal SSH keys within your Vultr account. And this is a great thing if you come to think, because many managed platforms offer that they manage all for you, while you don't have this 100% control over the privacy, over which exactly a version of Docker image is used. With dstack, we try to give developers as much control as possible. And dev environment is a very basic and trivial thing that everybody wants to have. Just, can I use my favorite IDE with just the GPU that I need at this particular minute? Now I need a H100, tomorrow I need something else. And with dstack, you are not leaving your Git repo. You just invoke one command, and now immediately switch to inside the Vultr compute. And Vultr offers a lot of GPUs to your choice within the quotes that you have, and allows you to untap to that GPU compute without asking any permissions and without having any red tapes within your team, be it called like MLOps team or platform team. Basically, this tool enables your AI team to manage whatever they want on their own without involving other people. Another example, now imagine that you've experimented a bit with the dev environment, and you want to run something a bit more complex, right? Like a training job. Same story here, you define a configuration, you just set type to task. But now you also can specify the Docker image if you really want. You can specify what GPU resources you need. Also, with dstack, you can specify how many nodes you need. By default, of course, it could be one node, but often you might want to actually use a cluster, because if you are doing something heavy, you would greatly benefit if you throw more compute. Great thing here is that Vultr provides high-performing clusters, which come with infinite band. And this is where GPU are interconnected through infinite band, so you can save a lot of time and eventually money, but just basically expanding this compute to multiple nodes, more than one. Great, again, part here is that now you don't have to involve any MLOps or any DevOps. You just say, this is my script. This is the framework which I want to run. Let's say Torch-Run or Megatron or some other framework. It doesn't really matter. You just specify how exactly to run the script. What dstack does then, if you do dstack apply, it understands that you are running you are requesting a cluster, and dstack would first provision the master node and then all the worker nodes, ensure that the network is set up and it's highly performant according to the standards that Vultr provides. And then it runs the script on the master node first and then on workers. You can also notice that we have here environment variables which we refer from here. Those environment variables are passed by dstack, and they tell you which node is master node, what is the IP address of the master node, how many GPUs inside well, the instance, and this is how you instruct the distributed framework such as Torch-Run or Accelerate, doesn't really matter which one you use, to how to run it as a cluster. Everything else, it's not magic, it's taken care of by the distributed framework. And this is the best part, because dstack doesn't want to, you know, kind of create any magic here. We want to provide 100% control over what you do. If you do it without dstack, if you just run your script like manually on master node and then worker nodes, absolutely same process going on here, except that you don't have to do it manually. You are doing it through their configuration and then invoking dstack apply. Right, and with that, you can do distributed training. It could be small fine-tuning. It could be pre-training large models. Dstack handles of interruptions. It allows you to mount volumes, which I mentioned earlier, to persist data. And basically, it eliminates the need for MLOps team within your company. We have nothing against MLOps teams, but we really want to enable AI teams so they don't have this red tape, and nobody says no to you when you ask for compute and running something within the quotas that you have configured, right? Tasks can be also used for any sort of batch jobs. You can actually use Spark and Ray to process data. It doesn't really matter. dstack is not opinionated in terms of what you do with tasks. Tasks just allow you to run any distributed framework, or it doesn't even have to be distributed, over the compute that you've linked here, and we are talking about Vultr. And this enables you to run any batch jobs on Vultr without any magic, but with 100% control over what you do. Next one is services. As I mentioned, sometimes you want to experiment with a model. You want to basically deploy a model. Model can be complex, super large, small, doesn't matter. You may want to have a say in what framework you want to use. There is a preferences to use VLLM, SGLang, TensorRT-LLM, NVIDIA NIM. You can choose any. But with dstack, we allow you to specify what exactly you want to run, which model you want to run. It could be from Hugging Face, it could be some custom model. And then if you really want, you can also specify if you want dstack to auto-scale that endpoint. And once you do that, and you do dstack apply, dstack will take care of running that, auto-scaling that based on their loads, and then also providing this model as a secure, auto-scalable endpoint. And it's just enough to invoke dstack apply. Now, once the model is up and running, you can share this endpoint URL with the rest of the team. As long as they have access to that project, they can start building RAG, they can embed this model into their product. And because of the endpoint has this OpenAI interface, it means that you are not bound to any specific format. You basically just work with OpenAI compatible interface. Means whatever the RAG frameworks, agent frameworks you are using within your company, it will just work with this any model that you run with dstack. Right. Fleets, it's another example. It's not something that we are used to as an AI teams because of these red tapes everywhere, and clusters always something like super expensive, super complex, and we always want to ask somebody, can we have access to the cluster? dstack is here to change that. dstack wants to enable the AI team to remove that red tape and let your AI team to basically tap to the compute and have a control over the creating, provisioning, and accessing clusters. With dstack, we call cluster a fleet. A fleet basically is a group of instances, and you have control over what kind of instances those are. Is there a cluster that is interconnected with a high-performance network? Is it a cluster of disconnected machines? What size of this cluster? You can even specify the range. For example, I want a cluster that would elastically scale from 0 nodes to 100 nodes based on whatever you run there, right? And then, of course, you specify the GPU, what GPU should be present in that cluster. And then, just like anything else with dstack, you do dstack apply, and dstack would provision that cluster for you. So now this cluster appears as available to anyone on your team. So now whatever you run, dev environments, tasks, services, you can utilize that cluster. If it's a limited size cluster and you have more workloads coming from different members, dstack allows you to queue these jobs. And then you have a queue and you can cost efficiently reuse that cluster within the budget of yours. Right. And with that, I'd like to conclude and just walk you through the benefits and advantages that dstack offers you. First of all, dstack represents the rights actually of AI teams and developers over not being locked in into one vendor. It allows you to use your Docker image, your script, your Git repo, your cloud of your choice, which is Vultr, and then have 100% over the storage, fleets, and costs. To add here, dstack also does a lot of things under the hood. Starting from, let's say, collecting metrics. Whenever you run anything, dstack uses NVIDIA GCGM to collect hardware metrics. But not only that, it also collects cost metrics. And you are able to point dstack to your Prometheus, for example. And then if you have Grafana on top, you would be able to create a dashboard for your admin team or for anyone else to see what's going on. How many jobs are queued, what costs are this month or this day, what is running, and what is GPU utilization, what other metrics here. And with that, I'd like to finish, but I'm super happy to answer any questions. I'll be hanging out here, so come to talk about containerization, about dstack, and how dstack can be used with Vultr. Thank you.
Thank you.